Hello guys, I'm Shivang and today I'll be teaching you the basics of CPU scheduling algorithms in operating system. As you know, scheduler is a part where the process is moved from ready state to the execution state. And CPU scheduling is of two types. First, non-preemptive and second, preemptive. Now we start with the non-preemptive type of CPU scheduling algorithm. Non-preemptive is a type where one process executes and it finishes till another process can be moved to the next state of execution. So it first finishes the process that is going on before moving to the next one. Next one. So there are mainly three types of non-preemptive algorithms, which is FCFS, known as first come first served. Second is SJF, or shortest job first, and the third one is priority. The priority one decides which task is to be moved up on the basis of the assigned priority. So we go from topic to topic and we start from the FCFS. First come, first served. We can understand FCFS as in a line. When you go to a theater to buy tickets, you wait in a line and the person who is in the first gets the ticket first. Who comes first gets first and served first. So we can tell it by if the person P1 is coming first, followed by P2, P3, P4 and then P5. Then P1 will be served first, and after P1 is finished, then P2 followed by P3, P4 and P5. Let us understand the concept of first come first serve with the help of an example. Let us assume that we have 5 processes P1, P2, P3, P4 and P5 with arrival time as follows. The first process arrives at 10 seconds, the second at 10 seconds, third 10, fourth at 12 seconds and fifth process at 15 seconds. Now the burst time of each process is 4 seconds, 3 seconds, 4 seconds, 3 seconds and 1 second. The arrival time is the time when the process arrives at the ready queue, and the burst time is the time of which the process will run for the time. Now we have to calculate the waiting time and the turnaround time. Now, since it is first come first served, so we will look at the time frame. At time t is equal to 0 seconds, we see that none of the processes arrive at 0 seconds. So, no process is at 0 second. So, when we make the Gantt chart, we leave the time up to 10 seconds as idle. This is the time when no processes is being executed. Now we see that at time 10 seconds three process arrive. There is P1, P2 and P3. P1 has the burst time of 4 seconds, P2 has a burst time of 3 seconds and P3 has a burst time of 4 seconds. Now at 10 seconds, the first process will be executed as it is in the first in the ready queue. So we execute P1. Now P1 will run up to 4 seconds, so it will go up to 14 seconds. Now we move to time 14 seconds. At 14 seconds, we see that in the ready queue there is P2, P3 and P4 which arrives at 12 seconds. So we have the burst time of 3, 4 and 3. Now since P2 is second in the ready queue, so we run it after P1. It runs up to 3 seconds and goes up to 17. Now at time t is equal to 17 seconds, we have processes P3, P4 and P5. P3 has the burst time of 4 seconds, P4 has a burst time of 3 seconds and P5 has the burst time of 1 second. Now since P3 is first in the ready queue, so we execute P3. It goes up to 4 seconds up to 21. Now at time t is equal to 21 seconds, we have processes P4 and P5. P4 has the burst time of 3 seconds and P5 the burst time of 1 second. Now since P4 is first in the ready queue, so we execute P4 after P3. It goes up to 3 seconds to 24. Now at time t is equal to 24 seconds, we have only a single process P5 in the ready queue which has the burst time of 1 second, so we execute this process. P5 goes after P4 which goes for 1 second and goes up to 25. Now this is the Gantt chart of FCFS. Now we calculate the waiting time and the turnaround time. The formula for calculating the waiting time is starting time of the process minus arrival time. The starting time of any process is the time when it starts. So at 0 there are no processes and P1 starts at 10 seconds. So we calculate the waiting time of P1, starting time which is 10 seconds minus arrival time which is 10 seconds, and the result comes out to be 0. Now P2 starts at 14 seconds and is arrived at 10 seconds. So we have the waiting time of 4 seconds. P3 starts at 17 seconds and arrives at 10 seconds. So we have the waiting time of 7 seconds. P4 arrives at 21 seconds and has the arrival time of 12 seconds. So it comes out to be 9. And P5 starts at 24 seconds and has the arrival time of 15 seconds. So it comes out to be 9. Now we calculate the turnaround time. Turnaround time is calculated by adding up the waiting time and the burst time. So to calculate the turnaround of each process, we have to add up the burst time and the waiting time. For P1, the burst time is 4 and the waiting time is 0. so it comes out to be 4. For P2, the burst time is 3 and the waiting time is 4, so it comes out to be 7. For P3, the burst time is 4 and the waiting time is 7, so it comes out to be 11. For P4, the burst time is 3 and the waiting time is 9, so it comes out to be 12. For P5, the burst time is 1 and the waiting time is 9, so it comes out to be 10. Now we have the entire waiting timetable and the turnaround column, so we can calculate the average. So the average waiting time is calculated by adding the waiting time of all the processes, that is 0 plus 4 plus 7 plus 9 plus 9 divided by the total number of processes, that is 5. So it comes out to be 5.8. And for the turnaround time, we add up all the process times, so it is 4 plus 7 plus 11 plus 12 plus 10 divided by the number of processes, that is 5, and it comes out to be 8.8. So as you can see, here is the average waiting time of the FCFS process and the average turnaround time of the FCFS process. As we can see, there were major advantages with FCFS, like its fairness scheme. It means that every process gets the chance to be executed by the CPU. And the second and most important was that it is the most simple CPU scheduling algorithm. But there were also major disadvantages. The disadvantages include a very important topic, that is its average waiting time and average turnaround time were higher than the other CPU scheduling algorithms. Higher average waiting time and average turnaround time. So we needed a better scheduling algorithm than the FCFS.